Hello everybody, welcome to another stream. How are we doing? Hey there, my VAR, how are you doing, sir? Right, so last stream, we generated these two from a single shader, and well, these two materials from a single shader. And this was using the Voronoi noise, and applying a simplex noise on top for this one, basically, and then using that noise result, which is between -1 and 1, and mapping it into a color, basically. So very similar to a lot of the procedural map stuff that people do when they sort of make a procedural planet and put, when it's below ground it's water, when it's at ground it's ground, and when it's a bit further up it'll become grass or something like this, and then mountains. So it's a bit like that, but just for, there we go. But yeah, just for these things here. So we made this sort of like sandy stone looking one, I don't know, and then a sort of volcanic ground looking one. Now, I was thinking that I wanted to add a bunch of like a bunch of things to this shader, like Fractal Voronoi. So effectively you can get a bunch of smaller patterns that appear, and it just all combines. So I think we can show an example with a simplex noise. So if you have the non-fractal, this is simplex noise by itself, but then this is fractal simplex noise. So it's taking very low frequency and then making it higher and higher and higher frequency, and combining all of those results together. So that's known as a fractal Brownian motion, basically. So you do something like this here. We just call simplex noise multiple times at different different frequencies, and then keep so much of that result and then merge it in. So we can also do that with the Voronoi noise as well, which is the one that gives you that sort of like ground looking texture, basically. So I also wanted to add this sort of Voronoi noise hue shift based on the cell ID, so you can use Voronoi noise to do stained glass, basically. Is that what it's called? Yeah, like stained glass windows. Just getting completely doxed by Google here, but there you go. But yeah, like stained glass, maybe. Probably, if we put Voronoi. Yeah, you could probably do it something like this, right? This is the Voronoi noise. And then you can, you can give each of the cells a different color. So that shouldn't be quite hard to do. And then, yeah, that normal thing it wasn't anything. Yeah, better controls over 4 colors based on the height, basically, where they start and stop. Scale the Y up so we can stretch and hopefully make bark, because I was looking into people making like a bark shader toy, texture and shader toy, and I was thinking we could probably just stretch some noise and achieve that, and seems like someone's done something like that here. I think they've stretched the Voronoi noise, and they've got this. So if we have a way to stretch the sample position, we should be able to use it to make bark as well, which would be quite powerful. And you just shade it based on the noise value. You know, the black ones get sort of a darker color, whereas the lighter ones get a lighter brown color, that sort of thing. The thing about noise layers, Ronnie plus T. What does it scale the Y? I was trying to see if I can undo it, but it doesn't matter. We all get the gist of that. And the other one was domain warping. So have you seen domain warping on IQ? You know, domain warping. Essentially, you're taking the fractal Brownian motion and you're using the result to then offset the sample position of another fractal Brownian motion, and you just keep doing that basically. This is in a very simple maths expression form, but when you do it in across multiple dimensions, you need to do some extra little bits. But you can go from creating something like this, which is a regular fractal simplex or something like that, to something like that, and something like that. So we can add basically a way to do this sort of thing, which would be pretty cool. And then yeah, some way to combine different noises. This is what I wanted to add as well. So then it kind of got me thinking, right, you know, we're building this material editor for future me and some artists, so we can tweak some inputs and for faster iteration when creating new materials. And just by looking at these features, it seems like you can really make a lot with just noise and sort of a height, treating that noise result as a height and just basically shading based on the height, you know, adding a color based on the height. You can do quite a lot of things with this, with these features. So I'm leaning towards having a shader which can be used for multiple things and not just one particular type of material. Right now, because I don't really have any different ways of making different materials. So I'm thinking right now we should try and just make a shader which can basically combine a bunch of different noises, and you can do that in any order. Maybe you can probably add and subtract like some fixed constant or something as well along the way, and then have a way at the end to basically pick a bunch of colors, and that should be quite powerful. So in the past, with the thing which draws my UI, I've done this sort of like sign distance field. It's kind of like a virtual machine in a sense. It has a bunch of instructions that it processes in the shader, which means it can be super flexible, but it's kind of overkill for the UI. It kind of makes sense when you want to build a SDF editor to do stuff like that, but I just thought yeah. So for my UI, I probably want to downgrade that back to something more simple, but maybe keep that code around in the future anyway. But this idea of this sort of virtual machine, in a sense, we could just apply to this sort of noise thing. And I'm thinking we can essentially just have a bunch of like instructions, in a sense, which will be listed in an array, and you basically just process those instructions, and then at the end you should be left with one noise value on the noise stack. So there'll be a stack of noises, and essentially if we just have a way to sort of push on a Voronoi noise and then push on a simplex noise, and then have operations in ways to sort of combine those things or multiply, you know, add or multiply or lerp between them. And then, so this will push on a noise, this will push on another noise, right? So that's two noise values on the noise stack, and add will take the two values off of the stack that are at the top, and then push the add result onto the stack. So these operations are ways to sort of take stuff off, and these are ways to put stuff on. So yeah, I reckon for our first sort of material shader, if we go down the approach of making this one super general, and then at least it could be used to sort of do some, just to quickly play around without doing any code editing and see what sort of, just get some ideas and inspiration basically when making a material. And then if we need to drop down into anything specific, we can just go and make another shader and basically take the code from this one and just do it all in line, and maybe add some extra options in as well, which can be controlled from the game's UI, and so you can tweak the properties live as well. So, but I think with this shader we'll be able to make quite a lot of materials from it, so it should be quite flexible. We just want to be careful though not to go too crazy overboard with this. And you know, the next evolution of this would be make like a whole node editor, which is something we don't want to do. We just want to have a series of instructions basically that we operate on. So yeah, I guess let's get started on that. So if we go to the shaders C file, we'll keep the old one around just because I want to like look at it, but we'll add a new else if for material, and we'll just, right, let's make it 3. Alright, make it 2. So with the old one, these are all the sort of properties that you would basically upload from the CPU. And so we had this sort of like FBM thing, which is the fractal brownian motion. Now, I want to make it such that we could probably add a way of like a noise type basically. So I wonder if we could, yeah, it might be better to say this is the fractal brownian motion for simplex noise 3D. So we'll have a noise type of simplex noise, and you might have the Voronoi noise as well. I can spell that wrong, didn't I? For Voronoi noise. Or maybe these should all just be 3Ds. And then that's just FBM. Right. And then we'll duplicate this, I reckon. And then replace that simplex noise with Voronoi noise. Now, I think, right, we want to have one which returns a cell as well. Yeah, so we want another option which returns like a cell ID. Or maybe, yeah, was that Voronoi? No, I think the Voronoi would always return the We'll get to that cell ID thing in a bit. Let's just, yeah, we'll add it later. Let's just get the initial version up and running. Let's get this sort of like noise virtual machine going, and then we'll yeah, we'll add the features in. So one problem with doing this sort of very like this shader, which can be used for lots of different materials, is we can, when we change the code, is going to be obviously impact lots of different materials that we've already made. So effectively, we'll just have to keep adding features rather than changing how the features work. And we just got to be careful about how we do that. But yeah, if these functions are all in different files, then yeah, maybe the best thing to do would have a system which basically regenerates materials and checks if they've changed, but I'm very far away from that problem. I just got to keep it mentally noted down. So there's no point building that thing until we need it. Right, so I reckon we can have this sort of like FBM. So for now, I guess we'll say, should probably say 3D. Noise 3D. Okay, so I reckon we can make a... No, maybe we should make a general function that has a switch statement in it. Yeah, we'll avoid that. I don't think it gives us any gains. Maybe. No, it might do. Yeah, the problem is how we're going to get the Veroni noise cell ID back. If we had... Yeah, I guess we'll cross that bridge when we get there. Let's not just try and generalize it too much as well in the meantime, because we're trying to add features. Okay. Yeah, I also had this non-const thing. I think I should quickly make another global. Oh. I should make another global where it's like a U in max, maybe. So with this, it means we can do a little easy trick to make something not a constant. So we'll read it from global memory, this U32 max, and then min it with this value, and then they'll always return X, but the compiler doesn't know that. So when we use it in a for loop, it will not unroll the whole for loop and then duplicate all of this code many, many times. So that'd be very powerful. Okay. So the next thing we want to be able to do is effectively make that opcode just realized that that has to be declared afterwards because it's C. Right, so this will be the noise op. Now, here's the thing, right? So that with the noise op, are we... Yeah, no, I think this is okay. So let's type def the structure. I think this will have to be noise op code. And then in here, we'll put the opcode, and then I think we'll have like we can't have unions in shaders. So, and since this is only just used for a build time / editor thing, it doesn't really matter us ballooning up this structure, I think. So we'll definitely have the FBM in here. So this will be the Fractal Brownian motion. So this is if it's one of these two opcodes here, simplex or Veroni, this will be filled in, right? And then and then we'll have other ones like other opcodes such as basically multiply and add maybe. So you want to be able to, so you probably want to have adding an immediate as well. So I guess you just have the immediate. Like that or something as part of these two codes. You probably want to have a way to sort of change the sample point as well. So we've got to think about that. But let's just start with this one for now. And there's going to be more parameters involved with this thing. There's going to be like all the different colors, basically, and probably a seed. We should probably have seed as be part of the FBM. We got a thing for that already, which is good. And would you need a scale as well? Yeah, you probably want to scale on that noise. No, you wouldn't need that. Right, what else? And we need the different colors as well. So I reckon, so let's copy this structure. So you'll have a bunch of like colors. Oh wow. Crimson Mania, man. Oh my days. Wow. Dude, thank you so much. Really appreciate you coming in again. Thank you. Appreciate you, sir. That's incredible. Man. How's it going? How you been? Thank you so much. Really appreciate it. Oh, I duplicated that. Whoopsie-oh. Whoopsie, whoopsie. Yeah, so, thank you for Crimson Mania for giving all the subs out. That's just incredible stuff. Everyone who got a sub, by the way, you can get access to the code now. If you follow the link to the Discord here, and link your account, your Twitch account to the Discord, basically, you're getting access to a secret channel where you can get the GitLab link and run it and play it on your machine. So thank you to Crimson Mania. I'm doing good, having a quiet night, and just had some pizza. Awesome. Thank you. Hmm. Yeah, it's pretty chill. What pizza did you get? Was it pepperoni? Meat feast? So with the noise input, I think we're going to have a bunch of opcodes or operations. Now, we'll probably support to there's be a maximum number of operations. So noise, input, ops, capacity. And let's just say at most we'll have... We'll see, that's the thing, isn't it? Yeah, let's just say at most you can have 32. Now, I haven't done the domain warping either, but we'll add the features in a bit. Let's just get this set up. Then the other thing is about the colors. You want to declare basically different places where the I think you would like to put in noise. So depending on the noise value, let's say the final one is -1 to 1. We'll remap it into 0 to 1 at the end. And then all they've got to do is provide... You're providing a less than operation, I think. Yeah, so it's the boundary. Color boundary, something like that. So you have the color, and then you have like bound or boundary, something like that. Yeah, so I reckon you can then... Oh. Meteor pizza, right, yeah, so all of the meat. All of it. Awesome. Can't go wrong there. I've been quite enjoying lately just getting basically just getting some garlic bread pizza, and then I'll get some mushrooms and I'll chop the mushrooms up and I'll just like put them all on the garlic bread pizza, bung it in the oven. So I usually have like one of those a week at the moment. I'll get one from Aldi from the freezer section, and that's my sort of kind of like my cheat meal for the week. It's quite alright. Well, it's cheesy garlic bread of mine. Ooh, got a lovely little emote. There we go. Thank you, Crimson Mania. Oh, you got that one, huh? So, Yeah, boundary where the color will start basically or end. No, where it start. Yeah, where it starts. And then the color. Nice. Okay, so this is the input that will get passed from the CPU side from the editor, and the editor will have a way to sort of fill in. Oh crap. Then there's 4 color boundaries, let's just say. Color boundaries are a little bit long. Yeah, let's just say, or, color edge, even better. Boundary is way too long. Beautiful. Right, so let's get started on this super bananas code. So, yeah, we're not going to pass this up from the CPU yet. Let's just fill it all in inside the shader and test it all out. So here's the inputs. I guess we'll just zero initialize the whole thing. So input dot color edges. Let's do a simple red-green. So it's doing a less than operation. So we do edge equals 0.5, and then we can copy paste that and then just say color equal color red. I think that's the thing, right? Yeah. And then we'll copy paste. We'll do another edge. Now we don't really have... Oh yeah, we can leave the other edges. They're zero initialized, so we don't have to have a count, I think. So this will be a less than 1, and then that'll be green. Now input dot operations. Let's just put in the opcode of noise opcode simplex. And then let's take this FBM. Oh no, we can't. Right, there's some noise values up there. We'll reuse those. So because we've done the simplex noise, we use the other one, which is FBM, and that'll then be FBM dot lacunarity 2.5. Let's do a little bit of gain. 0.6 and octaves 8. Then we need to also put in a seed. Let's just use that seed up here. Right, and that's one instruction basically. Now I was thinking that we probably want a number of operations, but we could... Yeah, let's put up here color edges count. And let's put an ops count as well. There we go. Rightio. Yes, give that Bulma salute to Crimson Mania. You got the Bulma salute now, guys. It's good emote. Good old Bulma. And also, yeah, for those who missed it, if you got a sub, you also have access to the code. If you follow the link to the Discord, you can link up with Twitch, your Twitch account to Discord, and you'll get access to the GitLab and, download it and run it on your machine and all that good stuff, if you would like to do so. And for those who didn't catch the beginning, we're basically making a very general shader which allows you to pass in a bunch of kind of like virtual machine operations to a shader that basically runs a bunch of noise operations, and we can use that to make textures like these. So these are all made with the same shader with a Voronoi noise. Then on top there's a simplex noise, and then I basically took the noise result, called that a height, and then shaded it based on the height. And I made these two looking things, right? So really you can do a lot with just noise. So the idea is I'm making a very general shader for now. For this first material shader, it's just going to be a very general one, which allows you just to basically pile up a bunch of different noises and, you know, operate on that noise and maybe the sample point for the noise as well. And it's easily controllable from the in-game material editor, or it will be. That's the idea. And we can use it to quickly make a bunch of different materials with one single shader. Then if we want to do anything specific, we can just write a more specific shader. But yeah, that's what we're working on at the moment. So I'm hyper generalizing it and making a virtual machine, as you do. Because it's very fun to just overgeneralize stuff, you know? So I just have to get this out of my system. Right, so we've got this sort of FBM, fractal Brownian motion, which we're going to do to the Voronoi noise this time as well. So we can have fractal Voronoi noise, which would be quite bananas. But yeah, we've just done... Oh, we can test out fractal Voronoi noise in a second just by changing that. So the idea, we've got to put the counts in here as well. So it'll be, let's put them at the bottom. Input ops count equal 1 and color edges count equal 1, 2. Now, we're going to do a for loop over all of the operations. So op index 0 input ops count. Right, we extract out the noise operation from the ops array. We switch on the opcode, and now we simply just operate, perform the operation. So Voronoi, there was add mul and then add immediate and mul immediate. And then yeah, all right. And then we'll go around again. So essentially there's gonna be like a noise stack. So the noise stack is probably gonna be as big as we have operations. Right? And then we'll have another noise stack pointer, I guess. That is equal to 0. It's pointing to the first element in the stack. And all we do is just, yeah. So these is just going to push onto the stack. So that would just be the FBM simplex noise. You pass in your FBM structure, which is in the op FBM field, which we filled in here. Then we pass in the sample point. So let's get that sample point ready. What did I do in the past? I used the normal n. Right. So in that case, we have our sample point equal n in this case, and we'll probably have ways to mutate the sample point as part of the virtual machine. Is that lava animated? No. So we could animate it just to test it out, but the idea is that this is going to generate, because it's going to take a lot of time to generate these materials. Well, it's not a lot of time for a human being, but for a game frame, it's gonna be a lot of time. This one took about 30 milliseconds. So to generate a 4K texture for it. So yeah, we have some leeway to write some sort of like unoptimized shader code because it is running as a build step, but we don't want it to be so bad because we might want, you know, I think when you sort of press a mouse button, you do want it to sort of feel like it is regenerating live when you change some of the parameters. See, the idea is there's going to be an editor with these sort of procedural material shaders, which allows us to change some input values and see changes live, but then save the render out to disk, and that will be a material that will just be used in the game, basically. So we're just writing a very super general one for now, and then probably more specialized ones later on. This would be noise stack pointer equal that, and then we simply just increment the noise stack pointer like so. And now we just do the same thing for the Veroni noise, and then we, you know, have an add operation which is going to decrement 1, and then it's going to read a value so this would be A. Then it's going to decrement, well, okay, technically, right, you just do take 1, take 2, B. You need to take away 1 because you're going to put on, sorry, really that should be B then A, because A gets pushed on first, right? And then, yeah, we then put on the noise stack at the top of the stack. We put on I gotta be careful. Yeah, it's that way around. We put on the result, A plus B. Right. Cool. Then all we're doing here for the mul is just saying A multiplied by B, or with B. And then for add immediate, you're just getting 1, you don't change the stack at all. And you're just, sorry, you don't change the stack pointer at all, you just overwrite it with op.immediate. Right, so that should be an add instead of a multiply, and the other one is a multiply. So, hey there, Jmodorelli, how's it going? Welcome, welcome, welcome. So, this allows us now to add to the noise stack some noises, operate on the noises, and just go around in a loop basically until all the operations are done. We will have to be careful about these instructions can produce invalid behavior and then crash, right? So I wonder if that is the case, should we just render out a missing texture thing or something like that? We could sample the missing texture with a XY value, and then that will just say that you've basically got an invalid stack. Yeah, I think that might be a wise idea. But I haven't got the missing texture anywhere, have I? Yeah, let's Oh no, so if you've got an invalid one, yeah, maybe we'll just make it grey. Yeah, we'll just use a grey noise. We'll just, yeah, so we'll just say Boolean error equal false. So it becomes an error. Now, the problem is this damn switch statement now. So I might have to just give it an old. Repetitive background track is intolerable. What is that in reference to? Oh. Is it? It's not even playing anymore. Oh, you're talking about the, sorry. Yeah, that's the, because the gifted subs in it. Right, until then, we can just do this. Apologies for that. That is because we got, you know, a lot of gifted subs, which is awesome, but yeah. The Streamlabs thing just keeps going and going and going. Multiply. Add immediate. Then mul immediate. Just wait to focus, yeah. Just drone on to just something annoying. Just, you know, it's a one way how you can keep your cool. You know, just listen to something really annoying consistently. And then you'll be the nicest person in the world. Maybe. I haven't tested that theory out. So, yeah, now we can detect errors, right? So the idea is you go if this plus 1 is greater than or equal to the end of this, right? Because people are going to use this in an editor, so we want it to we'll probably want to gracefully handle the errors. We should probably catch these errors from the CPU side, but what happens if we don't? Or if we just catch them in the GPU side, we can display a feedback color to say that it is incorrect. And yeah, I don't know. But for now, let's just do it this way. So this one reads 2 off, right? So you need it to be at least 2 big. So wait, it has to be greater than or equal to 2, right? Yeah, so if it's less than 2, problemo. This needs 1 parameter on the stack, and there you go. Now, yeah, you won't even know where the error is actually as well, so maybe there's ways to encode that in the texture, I don't know. Right, let's just say if there's an error, you do something, if not, something else. So that's just going to set albedo to, you could probably just, you know, I can quite easily make a missing texture. I did it in, where was it? Fill invalid, this guy. Got it here is shader code. Right, albedo is equal to that. Done. Right, so we've not got an error. We're just going to shade it based on, so we've got those edges, right? Those noise edges. When I was learning, oh, wait, I missed someone else. Yeah, Balenciaga energy. when I was in when I was learning it, was hammering into me that condition branches are super bad for performance. Is this your experience? Right, or have people been blown up at? Yeah, okay. So, right, so I can talk about how GPUs work. So GPUs, if you have a conditional branching GPU, it's typically okay if all threads within the wave, so you have 32 threads running in lockstep typically. On some older AMD cards you have 64, and the modern RDNA 2 cards have a way of running in wave 32 or wave 64 mode, which in the latest Vulkan 1.3 I think you could basically, when you compile the pipeline, you can hint at which one you want. It's an extension called subgroup something. Anyway, so in my one, I always hinted to try and be wave 32, and yeah, so you run. So effectively, all it's not really 32 threads, right? It's a SIMD unit. So if half of them go into this one, you're gonna have to, this if statement. It has to execute this branch of the if statement with half of the threads inactive, and then it will check the next if statement. Half of those, so 8 of them will go into here, and then you check this if statement. There's none of them that go into there. And when 8 of them are going into this one, you'll then have 24 inactive lanes, right? So branches, when you have branches and you can't guarantee that all 32 in a wave are going down the same branch, you will have you won't be utilizing the full power of the compute unit basically. Now, there is another factor involved with branches, and that is register allocation. So you have things called a VGPR. Oh, this is AMD speak. I think NVIDIA has a similar, I forgot what NVIDIA does. And you have SGPR. This is just basically stores, this is called a vector general purpose register, and this is called a scalar general purpose register. What this one stores is a different value across all of the threads within a wave. So this is essentially when you have an and this scalar general purpose register stores the same value across all the threads within a wave. So this means, right, anything that comes from a buffer that is loaded with an SGPR as the index will always return a value which goes in an SGPR, because all threads within a wave are going to fetch the same value and it goes into the SGPR. If you index with a VGPR, this will be stored in a vector VGPR. So, because each thread within a wave has a different value, right? And how does this matter with if statements? Well, because if one of your branches allocates a lot of VGPRs, it basically means that it's like a structure. It's like having like a union in a sense of like, what's the way of saying it? Each of these sort of branches are going to allocate a certain number of VGPRs, and the one with the maximum amount of VGPRs is what you will allocate for all of these. Wait, would you? Yeah, it's all to do with like lifetimes of how long a variable lasts and all this. It probably a little bit hard to boil it down into something concrete, but yeah. So you got to be careful of how many registers you allocate, because the more registers you allocate in a shader, the less of them that can run. The less of them that can be paused in a compute unit. So another thing as well as a compute unit, so short for CU, I think these days on a modern RDNA card supports up to 32 compute units which it can switch out. So when it gets to an instruction like a memory read and it's waiting for the memory to come back, instead of just waiting there doing nothing, it switches out to another compute shader which is ready to go, and it just operates on that. So when you have a bunch of VGPRs being allocated in a shader, I think there's something like a VGPR file of, let's say 1024 for the whole compute unit. Well, if you're using 256 VGPRs in a single shader, you only can have 4 shaders which can actually switch out on a compute unit instead of 32. And so if you want to have 32, you obviously need to use probably 32 VGPRs, but that's quite easy to go past these days. So maybe going past it a little bit is not that bad, but when you go all the way up to 256, it's probably a bit too much. And there's obviously there's more things in VGPRs which can cause you to reduce that limit of how many shaders which it can switch out to. There's also the LDS memory, the group shared memory. If you have too much group shared memory, it will also do that as well. But yeah, that's a quick to do on shaders. Yeah. So worst path in terms of branches. So the worst path in terms of branches and registers can affect the entire group of threads. Yeah. Yes. Yep. Basically it. So you just got to be very careful with that sort of stuff. But in this case, since we're just writing it for like a build time shader or like an editor time shader, this is not the end of the world. But yeah, this is bad code for runtime games though. I would not write code like this. Right, we're nearly there. So we want 2 edges. So just got to do the edges now. So I'm going to go over all the edges and color based on the edge. Right, so edge input color edges index.edge color sRGB to linear. Awesome. So what we're saying is if the edge, so it's also an error if you haven't fully yeah, it's a baking shader. Yeah, exactly. So yeah, it's only just for editor time basically, or baking. So it'll still be quick enough. highly parallel. It can currently do a 4. The ones which generated these ones were 30 milliseconds because it was doing 3D noises, and they're quite expensive. Or 3D fractal noise, or fractal 3D noise. Yeah, expensive. Right, so I guess your color. So you're saying if the edge, so you want to get the noise. So noise value, you get noise stack. So if you're at 0, that's something we got to be careful at as well. Yes, you got to have at least 1 on there, right? Yeah, so it'll also be an error if noise stack pointer equals 0. Yeah. So yeah, there's ways that we can probably improve this error checking, but for now, I'll just do missing text. When we get the editor in, we'll probably have ways of identifying it in the editor, maybe. I don't know. So if the edge, so what we've got to try and find is like, yeah, I wonder if we want like a smoothness at all. So if you get the sort of the edges, you know, maybe let's just get it in. Let's just say, right, if edge, if noise is less than edge, we'll just assign a final color. So we'll call this one C. Color equals C, then we won't break because it's got to go over all the edges. Let's just do that for now. And then we'll output the albedo equal color. Emissive is equal to color as well at the moment. I think we'll sort of miss that later. And then the height is actually noise. Yeah, maybe we should call that height, I don't know. Right, what other things we wanted to sort out? So there's emissive strength as well. I don't know what we're going to do with emissive strength. We'll have to have ways of getting that to work somehow, based on the height you get back. So yeah, we'll put emissive strength to just 0 for now, but we'll try and remember to do that one. Yeah, I want to combine these two into a single texture. Metalness and roughness, again, I don't know how we'll do these, but we'll figure it out. Right, so that's the shader all ready to go. First version of it, where we at least have some sort of virtual machine evaluating or interpreter, and you know, here's the input data basically. So let's get going and see what we need to do next. So that's not an array apparently. Right, whoops. Swap to 4 edges, please. Right, so right, that was the wrong one. So fast 4 because it's a vector 4. Right, so you get like a green color show up. So green was the final edge. Oh crap, it was the final edge. Yeah, it's always going to show green, but at least we know it works. Yeah, I think maybe we do want a break. Yeah, I think we do. But we do want to make it smooth at some point. Maybe we'll do that next. Right, so that height we should probably multiply by 0.5 plus 0.5 to make it 0 to 1 rather than minus 1 to 1. Right, I should be expecting to see... Let's just make it rough as well. We're getting too much sort of... Oh no, we'll keep it at that for now. A nice sort of plasticky looking thing, you know. Right, so why is... So we're not getting an error, that's good. So it's going in, putting the noise on there. And up in the pointer, we take 1, get the value out. Go over here, it's obviously getting green. So yeah, it's just very, very strange. Why are we missing... Why are we not seeing simplex noise, basically, right? We're passing in n, which is the normal. And then the sample point is going into the FBM simplex noise. FBM has been filled up with stuff. The edges are at 0.5 and 1. I guess let's put it up just a little bit. The other edge. Right now it's red, completely red. Very bizarre. Seems like they're all at the same value. Yeah, somewhere between 0.5 and 1. Or 0.5 and 0.6, somewhere in between there by the looks of it. Okay. So what did we do with the simplex noise up here? So it was called FBM. Oh, we had the seeds and stuff, but we didn't... Oh, where's the seed? Yeah, so inside the FBM, let's say point equal something like that for now. Yeah, I'm not seeing any red. Showing up on this. We should be seeing some noise. Right, N is the normal. Let's try the Veroni noise and see what happens. Right, so both the noises are reporting back something just incredibly wrong. So it must be outside of that. So we take a look. One operation, two color edges. Let's just put on the error for now to see how the error looks, at least. Oh, right. Yeah, so this is the error shader basically. It's like the valve missing texture, but you know, something painfully wrong. Now, there was that problem where that non-const macro that I was using with that little trick was causing a problem on the first run sometimes. And maybe that's... there we go. Okay. I have to reload it. Damn it. Not good. Yeah, so that was to do with the non-const, I think. This non-const thing I was doing. So on the first frame, this isn't filled in with a proper value. Yes. Right. Damn it. Right, let me make sure. Yeah. Have we got a frame index anywhere? I don't think we do. Is that in GPU land? Yeah. Let's make that publicly accessible. And I think it's in Vulkan. Okay, so it's all publicly accessible now. See what we're trying to do with that again? Yeah, so inside the graphics side of things, when we do this sort of test material, this used to do it when you initialize when you call GPU init, sorry, graphics init, which will then run a first command buffer which just initializes static data, but it doesn't write out to the swap chain image or anything like this. So, but the globals weren't initialized here at this point, so we want to just delete that. And when we run this test material shader, which we've been editing, we're going to say or ggpu public frame index equals 0. And this will contain the global. That global structure will be filled in for this command buffer call. Maybe not. Well, one can hope. Damn it. Where are those? Right. So the problem is it wasn't uploaded into the buffer just yet. So we moved this to after the upload. Put it in here for now. Order matters. Right, so then it will upload to the globals buffer the right thing, and then it will run my test. I've got to synchronize on globals. We're reading from graphics global. GPU globals resource, that's it. Just mark that as read only. That should do it. It might be frame 1. That's why. Because the initialization command buffer is frame 0, and then frame 1 is actually this one. There we go. Awesome. Cool. Right, so now we've got a little bit of noise here. Now the problem with this, so the green is the higher, and red is less than 0.5 basically, right? Now we're not getting any sort of smoothness between these, so we probably want to add a way for our noise to have a way of smoothly going between the two somehow. And you can do yeah, so you probably want to lerp it, right? Yes, you probably would need to do a lerp based on something. Now, the problem yeah, so you're reading the edges and you're saying if I'm less than this edge, sorry, if the noise is less than this edge, then use this color, basically. Then what you need to say is you probably need a previous edge value, and then you probably need a sort of a smoothness maybe in it as well. So you could have a previous edge, and you can maybe have like a what did we used to call it? Maybe like an edge smoothness. So from this edge, yeah, from this edge, what is the value before and after in which you would sort of smoothly interpolate it, basically? Yeah, I guess. Something like that. So down here, after we've got the final noise value, we just call it the height. We'll go over all the edges. You probably want to keep track of the previous edge. And yeah, the previous edge, so we can probably start the previous edge off at 1. Or maybe infinity. And then we could probably start we have the previous color as well, as probably black. Then, yeah, so be previous edge equal edge, and then previous color equals C. Now, you probably want a softness as well, maybe like a previous edge smoothness, I think I called it. So this would be 0. So effectively you're going to get the edge, and then probably the edge smoothness as well. Now, if your noise value, you know, sum, yes, if the previous plus previous edge smoothness, if your height or that sort of noise, right, is less than this, then, or less than or equal to technically, then yeah, there's, okay. Let's just write this code out first. So there's a height. Yes, then you'll basically say color is equal to, so your two colors, right? I guess I'd call this the, maybe just call that albedo. Okay. So you're doing like a lerp between the, so in this case you'll have the previous color and then the current color, and you can probably use smooth step here. Smooth step, so 32 for the two edges, right? It's it would be previous edge and your new edge, basically. Well, no, it's edge, previous edge plus edge smoothness. Yep, and you'll pass in the height value there. So this will remap whatever values previous edge to previous edge plus edge smoothness is into value between 0 and 1 based on where this height is in between these two things here. And then 0 gets you previous color and 1 gets you color. Cool. And then you probably want to do another one if your height is less than edge minus smoothness minus edge smoothness. Then what you want is a similar thing, right, where you've got color. Wait, yeah. Yeah, previous color and color, and it is edge minus edge smoothness to edge and heights. Now there is a problem with this code, and that is both of these if statements can be true. So if you have two edges where yeah, so I wonder, could we so you got the red, which is saying if I'm, it kind of ends at 0.5. Then you got green, which ends at 1. So there's this sort of like red to green border. And that should probably be controlled by the previous one. It should never be controlled by this one, maybe. Yeah. Mm, no, it should go both ways. Yeah, yeah, well, I'm not sure if it'll be if else though. Because the problem is both of them can go in. It's just a case of like, I wonder if there's a way where I can show it easier. Probably show it in Krita visually. It's like a gradient in a sense. I think anything will do in the color tools. There's some sort of like gradient. Yeah. So imagine this is like an edge. So what we had red, and then we had green up here, wasn't it? Yeah, so in terms of like how Krita does it, is that this is the edge, and then when you have a sort of a smooth, like it's a gradient, so it's just going to do a linear interpolation from here, right? So yeah, maybe we just do it like that rather than having edge smoothness. Just put. So yeah, you initialize it to the first value, the first edge value. Yeah, okay, and then you yeah, interpolate it, and then yeah, also the last edge as well, something like that. That makes the most sense. Right, so in that case, then I think we could just say edge at 0 would be red, then edge at 0.5. Yeah. So you'll say your previous edge is equal to input edges. That. There's no edge smoothness anymore, we're getting rid of that. And then we're saying input color edges color. And so we'll go over, you get the edge, no edge smoothness anymore. Right. So what's the new comparison? So the new comparison, if the height is greater than this edge, or no. Yeah, what you're trying to look for now is the next edge where it's greater. Maybe. So if this edge is greater than my height, then I take the previous edge and then basically lerp it based on the smooth step of. So if height is less than this new edge, maybe it is just smooth step between previous edge and this new edge, with height being the input. And then you just would do that. The problem is what happens if you don't have an edge, if this is never true. Like over here, right, say if you never found one, you probably need to initialize albedo, in this case, to whatever like the final one is, basically. Yeah, less than second edge is lerp, greater is a hard value. Yeah, exactly. So you got these hard So we pre-initialize the previous edge with the first edge, such that if the first iteration goes in, then the previous edge color and color would be the same. So you even do a hard color here as well, like that. Yeah. So interesting. Maybe we could start the first edge off at 2.5 and end this one off at 7.5 to just test it out. So we run that. Oh. We should see what we are hoping for, basically, is an interpolation and some hard colors. Cool, we're seeing some yellows, which is good. So we've got some yellows and got some green. We got some reds and we got some yellows. Now what we can do to make sure it works is, I've got hot code reload, so we can just test it out quite easy. Is if I make that 7.5, do we just see a bunch of red? Wait, what were we supposed to see? We see a bit of green. I saw a bit of green there, but that's not... Oh, there's greens there. Right, so this is where the green is actually about, okay, above 7.5, right? So if I put it down to 50... Sorry, 0.5, we'll see more, right? More green. Yeah. So it's just a hard cut there. Now if I bring that down, the red down to 0.25. There should be an interpolation going on. What? Yeah, we are seeing it. It's like, it's yellow. Goes to yellow. Although, let me up it just a little bit more. Yeah. There we go. Right, this seems to be working. Cool. Right. So that's will we say that's the color stuff sorting out? Now, the thing is, when you sort of interpolate between red and blue, you don't really get nice colors. So if we look at OK Lab interpolation comparisons, we've got OK Lab already in the code base. We could just go and use it since it's, you know, not done at runtime as well. So yeah, which one is which? I think this is the, well, let's just figure out. So let's just do red and green. So start color is red. Okay. So OK Labs in the top row, and then RGB interpolation is at the bottom. So you will notice that it's just a little bit more duller, whereas this sort of preserves the brightness more, right? Or yeah, so this one gets darker and then goes lighter, I would say. Whereas this sort of will, yeah, there's something about it. This just goes far darker. This one goes less darker. Maybe there's some other characteristics to it as well. But, you know, we've already got this in the code base, so why don't we just try that out? So effectively, we would do a OK lab. Right, linear 4. So we've got functions for these. So this is what we'll do at the end. So albedo so color equal color equal GPU, and I've got to go to my core shared where I've got the OK Lab stuff in here. Right, OK Lab linear to OK Lab. I need a 4 version as well. Right, linear to OK Lab 4. Cool. Right. That doesn't matter. Right, so we'll pass in GPU. Hey Rohan, welcome sir. How's it going? Yeah, less muddy is probably a good way of saying it. Yeah, muddy. How are you doing? What have you been up to? Hope things are going well. So this is linear to OK Lab. No, we're not doing any alpha here, so we could have just used. Oh well. Yeah, this should really just be all vector 3s. Dot RGB 3 RGB albedo.rgb. So this way color Oh, got to do the same thing again. Yeah. Okay. And so that'll be a vector 3. Good, good, good. So now I can just OK lab that like so. We should probably undo that actually. Right, linear to OK lab. And then do the same thing as well for the previous color. And then we will lerp in OK lab space. And then you do an OK lab space, right? Not OK LCH, just lab. So interpolate between those two, and then get the final result back, and then just albedo.rgb, RGB, RGB. Then we convert that from OK lab back into linear space, and voila. So let's save that. Hopefully we see it change live. If not, it'll crash, but let's see. I think it's crashed. Yep. No worries. Of course. It's a vector 4 lerp. Will this fractal noise generator also be used to generate the custom terrain like mountains, valleys, etc.? No. So this is mainly just to generate different. So what I did is I made these two things, right? So I made this, which is just a Voronoi noise, which gets this sort of outline pattern. And then I did a simplex noise on top and just multiplied it together and got this, and then colored it based on the noise value, which you get left is -1 to 1. So I turned it into 0 to 1. And then just shaded it from there, basically. You know, it was kind of like a yellowy color, then it went to red, and then it went to like a kind of a bluey black color. And then I added some emissive to the lower colors as well. And yeah, I got this lovely thing. And then I just changed some of the colors around and reduced the amount of simplex noise, and I got this thing. So it got me thinking that, you know, and I was looking on, I was wanted to do like a bark wood as well. So I was looking at shader toy for like a bark, see if someone's done some bark. And you know, they're just using the same thing, the Voronoi noise, and they're stretching it out along the wire by the looks of it. And you can probably generate a sort of a bark texture as well. So yeah, it got me thinking that what I probably need for my first material shader. So I'm going to be having a system where I have a bunch of material shaders, and you can have a bunch of input parameters for those material shaders. And you can tweak some stuff live and then save out a texture, and voila, you've got a material, full PBR material. Now, we probably want some more, we probably want some specific shaders at some point, but I think the first one is just better off just being kind of as general as possible. And it's just a way to combine a bunch of noises together, and then based on the height, pick a color and maybe change some emissiveness and maybe stretch the noise out or something like this. And yeah, we should hopefully be able to generate quite a lot of textures to begin with, so it'd be pretty cool. So it's for your shader engine. Yeah, it's for the editor. Yeah, it's for shaders, so it's only on GPU. But yeah, we might have some noise on CPU when it comes to editor things. Maybe we'll see. I do want to do something procedurally generated, so we're probably going to. Yeah. Well, I might do something procedurally generated. We'll see. It's not for a while, but I think that's what I'm leaning towards. Yeah, more shader stuff. Right, so we should. Dun, 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 dun. Right, that looks a bit different, I think. So if we take a look at sort of this area here, maybe. like this area here. Oh, if I comment out all of these, which do the OK Lab conversion, and if I save it, you'll notice that this color will change. The sort of between red and green will change. Yeah, that is very noticeable actually. So a standard linear interpolation, it looks like you lose detail in a sense. So that if you save this now, right? Yeah, it feels a lot smoother. It actually feels like it is smoothly. Ah, maybe. We definitely get more of the red in this case. I don't know. Yeah. Huh. But yeah, it's interesting. Let's see if we take another look at it. Let's look at this area here. Oh. What crap happened there? Oh, I took out the lerp. Let's get in there a bit more. Yeah, maybe it could be an option. It's a good point. It's probably an artistic choice, isn't it? Yeah, very good point. Yeah, it brings out the red more in this case. Yeah, that's a very good point. Let's do that. That would be good. So you'll add, I guess, another enum. Noise, color, edge, or color space. RGB. OK Lab. Hey there, Captain Chica. How you doing, sir? Welcome, welcome. How you been? So the lerp color space. Nice. So input dot lerp color space. OK Lab, for instance. So we'll go if input dot lerp color space is equal to and voila. Right, that didn't break. So you should just be able to change it by doing RGB, giving it a save. There we go. Configurable. You have to compile OBS from source? Oh no, is that on Arch Linux? Hey there Voodoo, welcome sir. Going good? Decided to go full crazy. Oh wait, I haven't set up my wobbly windows since I've installed this PC. This is KVim. If only. KWin. All about the wobbly windows. Wobbler? Wobbler windows? Yeah, bit of wob. Or all of the wobbly. Is there any new windows then? Maybe it has to restart. Now we'll see. I swear you didn't have to restart. Oh, there we go. Oh. Right, all the wobble. Maybe not all the wobble. I remember it being a bit too much. Good old wobbliness. Yeah, we're back. Bit too much wobble. Ah, that step on the wobble a bit too... Alright. Yeah. Oh, you passed the maths. Amazing. Congratulations. Awesome. It's broken. Oh my days. Ooh. It's not very good. How did I manage that? I updated my PC kind of recently, so I'm glad I've done that then. And not now. Because, yeah, you know, if you want the browser extension, that's another one as well. I had to get it through. Wait, does my FlatHub... I'm using it through FlatHub. Well, I hope it doesn't automatically update. Because I use it to get the browser plugin, basically, because it's not shipped in Arch by default. But yeah, doing a Voodoo, we're just... a high map. Yeah, well, basically, when we generate these last stream, we just use a noise to generate a noise value, and we're just calling that height, right? And so yeah, you could say it's a height map, and then we're just shading it based on that height. So yeah, so we're just making a way in shader code to basically pass in a bunch of data to say like where the edges are for the colors and interpolate in between those two basically, and then having a bunch of opcodes to basically push on different noises and stuff like that. So I guess this is where the fun begins, because we should just be able to change this to Veroni, for instance, and then recompile. In the future, you won't have to recompile and run. It says the Veroni noise, is that right? Oh, this is fractal Veroni noise. Right. Why do I not see... Okay, this is a bit insane. If we did red 0, green 1... This is fractal Veroni noise. It's probably too... There's something about these values which are probably too high. Maybe not the lacrinarity. Maybe... Do we need more gain, or is it just too many octaves? I've not tried this one out yet. I wonder why we're not seeing... Let's put 1 octave in there. Why do I not see the Voronoi pattern? Or Voronoi pattern, however you pronounce it. Right. Oh, yeah, there's gonna be like a scale thing as well, maybe. But yeah, why is that? By lacunarity and then... gain... Yeah, so we're seeing the Voronoi pattern here now, but it's just so faint. Oh, probably that's because the edges are just too far apart. Yeah. So we add more edges. So I guess let's just do more of a... You know, we could do those 4 edges. Those 4 different edge colors that we had up here. That could be a bit of fun. So let's just do the... There's the low color. There's the second low color. Hey Flowly Art. As a 3D environment dev, I've got huge respect for you. I can never do this in my life, and I'm grateful you can. Yeah, awesome. So you know, tried to monkey around with like shaders or anything like that, or like the shader node systems in like Unreal or anything? Yeah, John, like, it's it, isn't it? It's just too big. So we did 0.25, 0.5, 0.75, and then so edge 1, 2, 3, and then we need to say we've got 4 edges. So we plop that up to that one and give that a recompile. We should start seeing that sort of lava looking thing. No, no, no. Clearly not. Why? Oh, why? Well, the thing is I did it with no octaves, with 1 octave before in the past. Oh, it's multiplied by frequency, yeah, but that would be 1. Let's just... Alright, I've got Voronoi noise in there. Let's put that there. Let's put in sample point and do .x. See if that works. Right, it's the same thing. So what color is that one? That's where red is. So they must all be this. Yeah, they must all be this. So in the case of the Voronoi, put that thing back. they're all kind of very low values, I think. So we made this edge 0.1, 2, 3 maybe. Right, where's... Right, so it's getting the black value now. So I guess that's... Wait, now remember, did we have to invert the Veroni before? Veroni distance. What do we do with it? Oh, it's a distance, isn't it? Then it's been multiplied by 0.5. Oh, crap. Right, so that Veroni noise, we're going to need to, because it's a distance, we'll times by 2, take 1 on it to make it between, to make it assigned instead of unsigned. There we go. All right, so we're getting something more. And yeah, so the yellow is essentially inside the... So if you used to treat it like a sort of a volcanic ground in a sense, the yellow is the lowest part, the red is the part which is a bit higher, and the, you know, the black is which is a bit higher than that. So then you can... But yeah, so if we interpolated that in OK lab space, does that look better? I guess it just depends. Yes, we have it as an option at least. Huh. Interesting. Cool. No, I had it off. But yeah, I just turned it on. Noise normalized between... Yeah, so the noise... these FBM ones return a noise between -1 and 1 now. And then later on we take the noise and turn it into a height by turning it into 0 to 1. Yeah, so now let's add... So the thing is, we probably want to be able to scale this thing a bit because this is so damn big. But yeah, we've got a seed thing as well, so we can easily just change the one we've got just by changing the seed, which is pretty nice. Can we? Well, it worked before. I don't think... Okay, I've not changed the Veroni noise function with the seed, have I? Right, there you go. Done. Now, let's try the fractal thing about it. So you can up the octaves and you'll get... It becomes fractal, right? Bit too crazy there. So that's where it's a very low... Yeah, the thing is, it's a distance. It's I'm using a Veroni distance now. No, Veroni distance, aren't I? And then I'm turning it into this sort of signed value, which doesn't really make too much sense. Yeah, I wonder if we can use that Veroni distance function for this. Alright, that's alright. Or maybe. So we bring the fractal down, or the octaves down. I can see it's kind of faint. So if I up the gain, is it the gain? Right, the problem is the amplitude is 0.5 initially, so it's going to scale that value a bit. Yeah, so there's something, we might want that to be configurable, basically. To some degree, what is the initial amplitude? But yeah, so say if we put that back to the default one, 0.5, and then we put the, gave it a couple of octaves, gave it, 4 octaves, put the gain down to 0.5. Just whack up all the octaves. Yeah, so that's fractal Voronoi noise. We probably want a way to sort of change the scale of this as well, because the scale is just far too big, I think. Or it might feel like it's far too big, the initial one. We'll see. Yeah, I guess it could be lava. I had a better lava last time. But I guess it just depends, right? What's the size of the sphere that we're doing, and what's, it all just really depends. And obviously, right now this is very plasticky looking, because I've got my metalness at 0. But so we're seeing that sort of very plasticky specular there. Yeah. Yes. Right. I'm just gonna take a short break, and then yeah, when we come back, we'll see what else we can do today with this noise virtual machine thing. Right. BRB. Right, welcome back. In the first version, you added noise to the other pod depending on the simplex noise. Sorry, by appending simplex noise to the distance. Yeah, the lava have sparks and bubbles almost. Yes. So what we've got is operations, right? So we've got this thing called a noise stack, and this Veroni noise adds Veroni noise to the distance stack, or the noise stack. Then you can add, we can do it right here, right now. We can go and add a simplex noise operation, which will then add simplex noise to the noise stack. Then you can combine the two values on the top of the stack. It's just a little stack virtual machine with a multiplier like we did in the previous one, and you don't need any operations here because multiplier just takes the two off the top of the stack, or the two ones at the top, yeah, and then replaces those two with the result and leaves you with one. So to a specific edge, no, in the end actually I got rid of that code. Here's the old code. I did scale this differently, where I scaled the, we'll add a way to scale the sample point in a second. But yeah, we just did the Veroni noise, we got the distance, and then we just did a simplex noise, an fractal Brownian motion of simplex noise. And then you multiply the result of that with distance, and that was the height. So it's a very similar thing, basically doing it like this. So let's give that a go and see what happens. Right. Not looking good. Let's make roughness 1 as well. Right, okay. Interesting. Right, so something's gone wrong. Don't know what it is. We can change the ops down to 2 and it might still work. Right, we just got a grey color now. It's not an error. Still working. Oh, it's because these are 0.3s and all that in it. Right. Hang on a minute. Yeah, let's try that out. Oh, that's simplex. Is that simplex? Oh, linearity needs to go up. There we go. And then you probably want a little bit more gain, or is you want less gain? Yeah, just give that a go. So that's the simplex noise. Now, so it takes at the end, if there's multiple noises on the stack, it just uses the top. It always takes the noise at the top of the stack. So let's put the operation which multiplies them together. And so this is apparently Veroni noise mixed with simplex noise. I can't see it, not gonna lie. Let's move it back down to 1 op, where it's just the Veroni noise. Okay, Yeah, so there's the Veroni. So this here is where the Veroni is, I think. Let's go that back down to 1. Sorry, the edge. Maybe not. It's not really a good place to look at. Can I see a different side? Yeah, I need a way to change the scales of things. It's a bit too... But yeah. Right, so I think my next biggest problem is the fact that for the Veroni at least, well, yeah, I need a for the FBM, the fractal Brownian motion. I think I need a way to kind of scale across 3 different dimensions, which would be interesting. So we'll be able to do a lot of things with that. Does it only apply the last value on the stack? No, it only applies the last one on the stack, so you have to manually layer it yourself with the multiply instructions and that. Yeah. Yes, there's a multiply op here, which just basically, yeah, takes 2 values and then returns them multiplied. Excuse me. Right, so with that scale, let's just go back to changing the Veroni noise. But yeah, we could say times, let's just say it's 666, the devil's number. Or let's do 777. Let's avoid that one. Very dangerous. And then we can go to simplex. We'll probably stick 111 here. Or we can configure it. Okay, so inside those FBMs, when we initialize them, we can... Is it add afterwards? Add then scale, I would say. Yeah, so we'll say mol f, sorry, point and f dot scale before we do the octaves. Now let's try that out. Right, so that's changed it a little bit. We're going to go to the, just to view the Veroni noise now, just by moving the opcodes counts down to 1, so it just puts on the first operation, which is the Veroni noise. Okay, there we go. So we get in a more finer grain, finer detail Veroni noise there. Now, the problem with the Veroni was that's got a lot of octaves actually. Can we change that? Okay. So the problem with the Veroni, it seems like the right, and let's up it so we only see the simplex. Right, the simplex has a lot of dark areas here. Why was we multiplying it? How did the other one look as good as it did? What was the values for the simplex? Oh, the values for the simplex were these. Lacanarity 2, gain 1.05. Right, that's a little bit more crazy. Now, why why are we getting... I think this is what I wanted. Yeah, we're getting some odd artifacts there. But yeah, this is how it made it look crazy in the other one. So if we join the Vroni noise, which is this one. Wait for it. Oh, which is this one. There we go, Vroni, with that simplex which was before. Now let's combine them both. We still didn't get what we want. Why is that? Maybe there's something wrong. Interesting. So think about, but see the pattern is if the instruction stack was individual per field, so one stack for every field, not a single stack for the strut. This way things like scale does not need to be duplicated and only push the opcode that change. And like I said, fun to think about. Right. Right. Yeah, an invert does make sense. Yeah, maybe we should have an invert. Well, would it make sense though? Because you're getting some really dark values for some reason. Wait a minute. We multiplied in sign norm space. Whereas up here we multiplied in signed space. Right, let's have a bit of... With that... Yeah, let's try this out. Okay, so maybe what we do is the noise values we get back out, we always turn them into that. Don't have to do that anymore. And I think that's what's going on. Nope. Alright, it'll be the same effect then. Maybe. Yes, I wonder... Okay, there's no point changing that then. But yeah, for the simplex, if you invert it... Yeah, you might... Or maybe there's just an invert op, which just inverts the top. Yeah, that'd be a good one. We can add that. So you just have an... What would you call it? Probably just call it negate. So it just... equals negate. You could probably achieve the same thing with multiply by another immediate, but yeah. Let's test it out. So instead, let's do a negate. That should just invert that image. Oh wait, I need a third opcode. Yeah. So it just negates that one there. So if we were to that back down to 2. Yeah, there we go. Cool. That's not bad. Right. So what's the next thing that we want? Yeah, so why when we multiplied them together did it not produce a better result? Alright. So I wasn't viewing. Let's see if this changes anything. If I turn it to... I thought I tried it out, but I was thinking maybe it wasn't running all of them. Does that produce a different result? Yeah, it does. Right, so I think we'll do that then. So our noise stack is going to be... It's going to be in... It's going to be in unsigned space rather than signed space. Right, so it makes more sense. So the thing is about the FBM, right, it's an accumulated value, okay. Right, okay. Yeah, so I wonder why this is so much yellow. Is that just because that's probably coming from the Veroni? There's 2 octaves. Let's bring that down a bit. Yes, it's a horrible pattern. It's probably from the rand function. We need to sort that out. Well, we can run the old one. Let's run the old one that we had and have a bit of a play around with it. What's going on? So this should be the... Oh, it's not going to compile. Crap. No. I'll rename some functions. Okay. Oh, that looks very different. Let's turn the glow down a bit. What changed in this? Luckily I did commit. Right, so we just changed those 2 lines there, that's it. What? The simplex noise had the seed? Right, seed and scale. Yeah, they're not initialized. Let's try that out. Yeah, good point. You found it out. No. See. Yeah. This is coming from my crappy rand function that I've got in the FBM. If I get rid of that, There's that random 3 that I had from the simplex noise one. Let's just use this for now. That should produce better results. But it's got to be based on the seed. It's just scale up by the seed bit casted. We could do this sort of division for it. Right, it's probably better if we take the seed, we turn it into a float and divide it by the maximum int. And then add that to the point, then throw it into that round function, then add that to the point. Yeah. Something like that. Maybe it's a bit too much. What does random 3 get back? Yeah. Ah, right. Let's try that out. Oh, we're seeing some sort of hard edge here. That is disgusting. It's looking better though. Back to what it was before, kind of. So what's happening here? Is there a multiply by 0? Oh, it's based on the sample point. We can't be doing that. Yeah, is it there with other seeds? That's a good point. I think it's I think it's to do with the this though. If I remove it, oh wait a minute, this one. Yeah, it's not there anymore. It's something. It's because I'm. Yeah, I think I might be better off turning this into a float than scaling it or something. So unpack. As a vector 4, but then you won't get. You'll waste the higher bits, but that'll be okay maybe. And then RGB that. I'll get the XYZ right. And then scale it up by 256 or something. That might be good enough. Oh yeah, plus 0.1, yeah. To avoid the divide by zeros. I think it was more of just, it was some other problem maybe. But it could have been it. But there we go, so that's what it used to look like. So we've got to figure out why our new one doesn't look like what are we doing? Yeah, so I want to look at simplex noise, I think. So we just did noise instead. All right, so it had emissive and yeah, that's just seeing the emissive there, ignore that. Yeah, that's what the simplex noise looked like on its own. It's hard to tell because the edges. Oh, that's another point. My edges weren't really edges. It was kind of a lerp of a lerp. Right. Okay, so let's go back to the other one. Oh. Let's go back to our fractal noise VM. See what we got. So we should have fixed those problems with the repeating patterns, maybe. So, all right, let's just see the Veroni. So Veroni's a bit too much, really. I think the scale's a bit too high. Probably times by 4. Right. So you see what's interesting here is it's not producing yeah, so that's because these needed to be lower actually. So where's the yellow? The yellow that's a bit better. Now that red is too high. I think that's the red edge. Nope. So I guess let's do 4, 5. Wow. Maybe not. Right, so it needs to be 3, 5. Ooh. Why is this? Oh, I see, right, because the right, this needs to come down as well. No. A GUI like Krita would make setting courage is way easier one day, yeah. Yeah, it would actually, wouldn't it? That probably won't be too hard to make. The problem is I'm trying to build like a general editor. Maybe for this general shader, I'll just have a specialized editor for it, so I can do stuff like that. I wonder where the sort of yellow color is coming from. So this is the yellow color, right? Yeah, this is the yellow color. So it's right at the bottom. Right, so it's just the way the interpolation is happening, isn't it? Oh, we're seeing it there. If I was to drop... You can abstract the idea of the edge gradient and make a UI component for it. Then any shader with a gradient constant can use it. Yeah, that's a good point. It probably is going to be quite reusable, actually, isn't it, for materials? Yeah, that wouldn't be a bad idea. Yeah, so I wonder what's going on. Like what sort of value we got. Maybe it appears at 3. Yeah, so it doesn't appear... Right, so the lowest value is 0 0.0 is 0 0.3 or something like that. Well, 1 octave. Oh yeah, it's changed. It's times it by 0 0.5 or something, isn't it? Yeah, I remember that. Just messing up the value. Because it's like a distance, and then... Yeah, maybe we start the amplitude at 1 for Veroni. Probably makes the most sense. Right, let's get these going again. So... Yeah, it's translated into the same... Well, it's difficult to know what space it is, because the Veroni noise is a Veroni distance from the edge. And yeah, I'm just sort of trying to cheese it, basically. But yeah, it's definitely in the same range, though. So the Veroni noise is a distance from the edge here. Then I change it into signed space. So yeah, change it from unsigned norm to signed norm. And then just do the same sort of like noise stuff on it. And then turn it back into an unsigned norm. But yeah, we need to have a bit of a play around with it, to be honest. We need to see what happens if we add more fractal to it. So if we move that one down a bit and that one down a bit, it's a bit better. Thing is though, it's such a small valley. When you use Veroni. But it makes sense. Yeah, we try the multipliers. Good point. That's looking better. It's looking more like what I want. So we tried the if we had the multiple. So this is what the simplex looks like. Right, so let's merge that on top. So multiply them together. Oh yeah, we're in business. Awesome. Let's go back to the Veroni for a second. Let's make it fractal Veroni, so up the octaves. Right, that's interesting. So this is the thing I've want to play around with a bit. It's just too small now, isn't it? Yeah. There's something with this Veroni. Right, let's have a bit of a play. So maybe, just maybe, we make it always work in distance space. Right. Then we turn the octaves down. Right, okay, this works better. It preserves it more, the distance is more. So yeah, it's going to be an inconsistent thing about these functions, but there you go. So Veroni noise, you will have to document that if we keep it. So we up the number of octaves. Okay, interesting. Can we change the gain a bit? Yeah, the gain would... slowly change the gain. Alright, makes it less and less. Why the lacunarity? You barely notice them when the gain is that small. The gain has to be something meaningful. But you're multiplying very small numbers, I think, and that's where it just loses detail. The lacunarity, I don't think, is going to help here. Maybe it does. Alright. Right. So we up the gain. Yeah. So 1 octave obviously is just that. Problem is that multiply, it's a distance, and you're sort of merging the two. It's fine for when you haven't scaled it, I think. Standard Voronoi. Fractal Voronoi. See, the values are just too damn small. I guess I bring the gain down a bit. Ooh, interesting. Change the scale around. Yeah. I think this is good. So it's essentially adding more Voronoi to the path now. It could be so. Yes, in this case we would up the edge by ones probably, or 0.1s. Yes. And then we can add our fractal simplex noise on top. Bit too much, or we tweak the edge values a bit. I've just put them back down to where they were, to be honest, a second ago. And voila. Cool. That's really good. Right, so we're not even like there yet. There's still more features I want to add to this, but we've at least got the initial bit in. We've even got the scaling as well. So this, I guess we can mark this one off as some volcanic one. So we'll put that down here like this. So that's a volcanic shader. Now we can monkey around with another one, which will be something like, maybe try and make that wooden sort of bark looking one, maybe. Like, so I was thinking you could probably take the Veroni and then stretch it along the Y. I don't know what would happen if you put 12 down. See how that would look. Right, it's kind of the wrong way. Why is it? Hang on a minute. Let me animate this a bit more. Why is it? If I squish it on the Y. Yeah, this seems odd. This oddly seems the wrong way around. So if you take the normal, yeah, I wonder if we've got to. So maybe the sample point just needs to be multiply by 0.5, add 0.5. Put it into unsigned space, maybe. Then if you scaled the Y, would that change it? No, it still doesn't do it across the Y. Don't know why that is. Yeah, the dot x is just because that's where the distance is stored. The in the Voronoi noise function, or the Voronoi distance, because it's taken from IQ's, shader toy. The YZW is where he stores the center point for the cell, for the Voronoi cell, and that's what he's storing in there basically. So each cell has a center position. So I wonder if my local space or whatever is just a bit wrong. So if I was to up x to 12, scale of 12, does it do it across the y? Then if I scale the z, what does that look like? Yeah. Hmm. It's definitely pointing the right way. Yeah. It's weird. I think we can just color it based on, if y is less than, if n dot y is less than 0, shouldn't be too hard. Albedo dot RGB, which is going to be sine of normal y. Right, so either -1 or 1. Plus 0.5, something like that. Yeah, so, y is up. So what is my FBM scale doing? It's taking in the sample point. And it's scaling that point. Yeah, and the min-max. Yeah, min-max A. Yeah, I was going to add a lerp. Lerp is definitely going to be good. Because, yeah, you can sort of blend in the two layers, which would be awesome. But yeah, also min-max, interesting. Yeah, the problem with min-max is you will see edges and things. Maybe. But yeah, maybe I can add it in though. Wouldn't it? It's another binary op. Yeah, I wonder. So if I stretch the sample point, yeah, they're going across the wrong way basically, right? So if I just swizzle it around the other way. It might just do it. Color space conversion opcodes. Where would you, because there's no color in the virtual machine interpreter loop. The color happens at the end, but it just colors it based on the height at the moment, based on some edge stuff. There is color space though. That's about it. Right, let's try and up that Y. Let's up it to like 32. See what happens. Right. That looks like the Y to me. And the Z is across. Sorry, the X is. That's the wrong way. Swap that around. Veroni noise. There we go. I don't know why I need to swap the XY around, but we do. Cool. So yeah, we could probably make some sort of bark looking stuff just by doing that. The problem is you get that sort of look. So yeah, maybe the scaling isn't wise. What you want is you probably want it cylindrical. No, sorry, not cylindrical. No, maybe cylindrical, or maybe like a spherical coordinate. Yeah, the polar coordinates. To make that sort of bark look. You might get some stretching at the top though, which is what we want to kind of avoid. But we maybe can't avoid it sometimes. Yeah, it would lerp noises. Yeah. Yep. But I could add some operations for how to color it at the end. So you could put an operation down to say yeah, you could put down an operation to say color it based on this sort of edge data, and maybe there's another way to color it. I don't know. There's probably some other ways you can do it because I've done it with the sign distance field before. With a sign distance field, I did border. I also did texturing as well and all sorts, but that won't apply here. Yeah, I don't know. Have to see. What other features are we missing? Yeah, lerp is one. Let's put the lerp and min max in quick. So that would be min, max, and then a lerp. ABC. Or maybe our beta opcode is better. Better name, it could have a blend mode field. True. You could add the color space opcode and then move the color part into the eval loop. Right. Yeah, actually I think I did that in my sign distance field thing. Yeah, true. Yeah, that's true. We could do it that way. And then you can have different opcodes. Yeah, true. We are going to want to blend based on... Sorry, we are going to want to probably have different ones for metalness and roughness, isn't it, as well? Maybe. Different channels. Yeah, good point. Yeah, those might... Yeah, we'll see. Yeah, because I used to take the color... Yeah, so in my UI render... I've already done this in here because it's a crazy SDF operation thing, which only makes sense for an editor, really. But yeah, you can do color solid and that will... Right, so overrides the source color and it mixes the two together. Is that right? Yeah, it always mixes the two colors with a multiplier. So you could technically have multiple albedo things that just get multiplied together, maybe. Gets a bit complicated though. Okay. Yeah, come on. I'll be there in a minute. I'll jump. You get bed. You get bed. Yeah, I'll be there in a minute. Hmm. Yeah, you probably want to alert with an immediate as well, basically. But yeah, we still need to try domain warping. And yeah, this might have to map with a spherical coordinates. Can we test that out? Spherical coordinates. I've got that somewhere. So you would take... We've already got the normal. And that is... You've turned into spherical coordinates from the normal. Then you can stretch it along the y and spherical coordinates, and that will go all the way around the sphere. But then it will obviously look funny at the poles. But it's already kind of going round anyway. Right, catch you later, Myvar. Yeah, thanks for popping by. I'll see you in a future one. Have a good night, sir. Yeah, so I reckon we can play around with moving that into spherical coordinates. Can I do that? I've got a spherical, 2 spherical chords. Let's try that out. Yes, it's got the poles here. And with some odd looking. I've got to be careful of doing stuff in spherical coordinate space though. And that is because we get that sort of pole stretching, which is, we was trying to avoid it by doing it in the octahedral map in the first place. But I wonder if we'll have to do it to get some of the textures to look good maybe. Ah, ain't working. Right, let's put it back. So that's what we'll figure out next time. So at least we got the, you know, we've basically re-implemented the previous shader that we had last time in this more sort of, this one which we can use for just doing tons of noise operations and combine them together. So now it's just a case of adding all the features that we could possibly want to this without making it too crazy complicated. So we need to find a way of stretching it to make bark. That's the next objective. And then we need to add stuff like the domain warping and the cell ID hue shift on the Veroni. Ah, that's where the different color code, the color things could come in. Yeah, so probably different color operations and stuff like that. Awesome. Right, I guess that'll be it for today. So next stream will be on Thursday. I'll push this code up to the GitLab for those who have access to the source code. So yeah, thank you for supporting the channel, everyone. And yeah, if you're still here, Crimson Mania, big shout out to you, sir. Appreciate the all the support today. And last month as well, is really cool. Right. Let's raid Kujuk. Yeah. The Jai guy. Alright. Hope everyone has a good Wednesday and hope to see you all on Thursday. Right. Catch you later, guys. Bye-bye.